everybody, so I'm going to be talking about 14.6 directional derivative and gradient. So basically our gradient is the direction vector of our function, and our directional derivative is the amount of change that happens to our function in the direction of our gradient. So I found a couple examples online that I will go through. So for our first example, the equation they give us is x cosine xy plus z squared y to the fourth minus 7xz. And ask us to find our gradient. So I guess when we're finding our gradient of our function, we're basically taking the partial derivative based on each variable to find our x, y, and z components. So if we start with, our partial derivative of our function based on x, look at our first part. We have two equations with x, so we have to use the product rule. So first part is just going to be cosine x of y plus x times the derivative of our second part, which we are going to have negative sine xy times y. This will go to 0 because there's no x. This will just stay at minus 7z. Then we'll go partial derivative based on y. Here we're going to have minus x sine xy times another x from the inside, so it'll be x squared plus 4z squared y cubed, and this will go to 0. And our partial derivative with respects to z, first part will just go to 0, there's no z. Second part will be 2z y to the fourth minus 7x. So if we lay it all out there, our gradient will be cosine xy minus xy sine of xy minus 7z. That'll be our x component. Y component, negative x squared sine of xy plus 4z squared y cubed. And our z component, 2z y to the fourth minus 7x. And that is our direction vector or gradient of this function. Now if we want to find the directional derivative of a function, we have to take our gradient and multiply it by a unit vector. So we were not given a vector in this equation, so we won't be able to find our directional derivative without a vector given. So my second example, we have a function of x squared y cubed minus 4xz. And the vector that they give us, negative 1, 2, and 0. So first we need to find our gradient. Should be fairly easy with this equation. So our x component is going to be 2x y cubed minus 4z. Our y component is going to be 3x squared y squared. This will go to 0. And our z component, this will go to 0. We'll just have negative 4x. So this will be our gradient of this equation. So now we need to find our unit vector. And a unit vector, as we know, is just a vector divided by the magnitude of the vector. So we'll start off and find the magnitude of the vector, which is just the square root of each of the points squared. So negative 1 squared will be 1, 2 squared is 4, 0 squared is 0. So we have the square root of 5 over our vector. So our unit vector will be negative 1 over the square root of 5, 2 over the square root of 5, and 0. So to find our directional derivative, we take our gradient, 2xy cubed minus 4z, 3x squared y squared minus 4x, multiplied by our unit vector. And when we multiply, we're going to take our x by our I, y by j, z by k, and we'll add them all up. So our first part, we're going to have negative 2xy cubed plus 4z all over the square root of 5, plus our second part, we'll have 6x squared y squared over the square root of 5, and our third part will just be left at 0. So if we combine like terms and maybe take out the square root of 5, our directional derivative will be 6x squared y squared plus 4z minus 2x y cubed, all multiplied by 1 over the square root of 5. So basically, if we decided to pick a point on our function and plug it in, our x, y, and z, that would give us the amount of change, in this direction that is happening at that point. But basically, it's just a general equation for our directional derivative, or the amount of change in this direction that is happening over the course of our equation. So that wraps up 14.6. Hope you learned a lot. Thanks. Bye.